Hello everybody, welcome to Dr.K.Liu Maths channel. This question is also very important matrix rotation and linear transformation. Very important linear transformation. It is so-called a reflection about a straight line which is equal to y equal to tangent theta. Theta is actually the inclination of the straight line. If we reflect this one, reflect along the y equal to tangent theta times x to become this one, we can see that the transformation matrix should be equal to cosine 2 theta sine 2 theta sine 2 theta minus negative cosine 2 theta. How to prove this one? We first observe that if this one is R, I think you can see that if you after reflection, the length is invariant. The length is invariant because this is right angle and this angle are equal. I call this angle is phi. Okay. And the length also invariant. Therefore, we can see that I first let this xy to be the original coordinates. It means all coordinates, original. And this is real, capital X and capital Y. And how to prove that? We first if we let the reflectional angle, this angle is equal to phi, then this is equal to theta. This is theta minus phi. Then we write the coordinate of x. X is equal to r cosine theta minus phi. Y also equal to r sine theta minus phi. Then expand this one, r cosine theta cosine phi plus r sine theta sine phi. And this is r sine theta cosine phi minus r cosine theta cosine phi. I think we can write this as in matrix form, that is xy equal to the r put outside, factorize outside, and then this one is cosine sine. Then we have a new matrix. It is a tube that has a matrix multiplication, that is cosine theta sine theta negative cosine theta times cosine phi sine phi. Oh, so crazy. Okay, let's look at the capital X and capital Y. Capital X should be equal to, yes. Similarly, the angle should be theta plus phi. Then it is r cosine theta plus phi. Expand this one. Actually, it is equal, similar to this one. I only need to copy this one, but change the sign here. This is negative sign. And also the capital Y, r sine theta plus phi. Expand this one also. Then we also obtain the similar format. We only change this one to positive. Okay, then capital X, capital Y can be written as the similar form. This is cosine theta. This cosine theta negative sine theta, sine theta cosine theta times cosine phi sine phi. Then the linking of these two equations is this one. Therefore, I make this as the subject. Okay, I erase this one. And multiply this one into the right hand and left hand side by the matrix multiplication. That is our cosine phi sine phi equal to xy, small letter xy, the inverse of this one. Inverse of this one matrix. Then I only need to check that the determinant should be equal to a negative 1 over. Therefore, 1 over negative 1 over determinant, and then exchange these two things, cosine, negative cosine theta. Then give negative sign to this 1. That is the inverse of the of this matrix. Okay, and then this is equation 1. And put equation 1 into 2. We have this one. I copy here. This 2 is equal to this one. So crazy. Yes, I also multiply the negative sign into this matrix, so make it become nice. Now we have almost finished our proof, because we have to show that this the multiplication of these two matrices is actually the multiplication of these two matrices is actually equal to this one. Okay, let's go to the detail. The first one, cosine square theta plus sine square. Sorry. I make mistake here. Change this one to sine. This also negative sign also. Therefore, it is positive. Okay, and then therefore this is minus sine square theta. And then the second one, sine cosine plus cosine sine. That is 2 sine theta cosine theta. Small letter xy. And for this part also 2 sine theta cosine theta. Also for the last one, sine square theta minus cosine square theta. Then the first entry should be equal to cosine 2 theta. The second is sine 2 theta. This is also the third, also sine 2 theta. The last one is negative cosine 2 theta. Therefore, in this case, the reflection matrix about y equal to tangent theta times x is actually equal to this matrix. That is the proof of the reflectional matrix. I hope guys can enjoy this video. If you find you have any difficulty in solving your problem, you can send me an email to me. I hope I can solve your problem soon. Okay, bye bye.